Alright guys, this video we are going to start with, we're going to have polar coordinates and we want to be able to convert it back to rectangular coordinates where it's x and y. Alright, and there's really going to be a couple basic formulas that we're going to use, and to get those formulas or to derive them, we're actually going to go back to drawing right triangles. So you can see we have this point right here. Now we could put this point as saying x, y, or if it has the same location, we also could put it in terms of r and theta. Now, if I look at x, y, right, x is going to give me the horizontal distance, and y gives me the vertical distance. So it's actually going to give you two parts of a right triangle right here, the horizontal and vertical side. So if I put that in here, from here to here, this represents the x value, and then all the way up there represents the y value. Now if we drew a hypotenuse for this right triangle, this represents the radius, right? That represents the distance from the origin to this point right there. All right, and then theta would just represent, remember, from the initial side to the terminal side. So this is theta. All right, so to kind of connect rectangular and polar coordinates, it's really like just drawing right triangles. Now, there's many things we can state. Now, obviously, it's a right triangle. So one thing we're going to do is we're going to use SOHCAHTOA. So if I use this right triangle, one thing I could do is, let's say, if I use cosine of theta, right, cosine's adjacent over hypotenuse. The x is the adjacent side. The radius is always going to be the hypotenuse. Okay, I might as well put y as the opposite side. So cosine of theta is going to be adjacent over hypotenuse, which is x over r. And then if I wanted to get x by itself, I would multiply by r on both sides, and I would get x to equal r times the cosine of theta. And then if I wanted to do sine of theta, this is going to be opposite over hypotenuse, which is y over r. And then if we want to get y by itself, I multiply both sides by r to cancel this r out. So we're going to have y equals r times the sine of theta. Right, which really, this kind of makes sense because when we dealt with the unit circle, we always said x was cosine and y was sine. Well, because you're really using this, because in the unit circle, r is 1. All right, so what this is going to enable us to do is if I have r and theta, I can plug them into these kind of formulas right there to get x and y. All right, and that's what we're going to do for these problems for 1, 2, and 3. All right, we're going to use this right here. All right, so I'll move this down. Okay, so for these, it's saying find the rectangular coordinates for the following polar coordinates. Well, what I like doing first is given a visual, let's figure out which quadrant are these points in. So I always like just kind of like doing like a rough sketch. So let's see, I always go to the angle first. 5 pi over 6 is in the second quadrant, and the radius is positive, so it's going to stay there. Now the reason why I like doing that is because when I get x and y, if I'm in the second quadrant, the x value better be negative, and the y value better be positive. All right. Now, when I look at this, r is 3, and then theta is the pi over 6. So to get the x, we're just going back up to this right here. And I'm just putting r in it, which is 3, times cosine of 5 pi over 6. For y, it's going to be 3 times the sine of 5 pi over 6. All right, so not too bad. All right, so when we do this for x, it's 3 times the cosine of 5 pi over 6. Okay, 5 pi over 6, that's in the unit circle. Let's see, the pi over 6's, the x values are the root 3 over 2's, but that's in the second quadrant, cosine's negative, so it's negative root 3 over 2. So when you multiply, we get negative 3 root 3 over 2. Okay, that's the x value. Okay, the y value, we're just doing r times the sine of theta. So it's 3 times the sine of 5 pi over 6. Okay, sine of 5 pi over 6, that's up in the second quadrant. So sine, or the y value, is still positive. Sine of pi over 6 is 1/2. And then 3 times a half gives us 1/2, or 3 over 2. That's the y value. So this right here, this point, 5 pi over 6, it's also the same as saying negative 3 root 3 over 2, and then 3/2. That's what this same location is in the rectangular coordinate system. All right. Let's see. I'm just going to do one more. I'm going to do number 2. Now, number 2, you can see this is not a special angle in the unit circle. So you would need your calculator to do this, and you would have to make sure it's in degree mode. All right. So I'm just going to do this one. Let's move this over. All right. Okay. I'm not going to do number 3. I'll just do number 2. So kind of slide this over. Again, if I graph this, let's see here, negative 200 degrees, that would be the same. If I added 360 to that, I would get, 160 degrees? So this would be in the second quadrant. And the radius is positive, so it's going to stay in the second quadrant. If the radius was negative, remember, it would flip over here, but we're not going to do that. All right, so just like number 1, the x value should be negative, the y value should be positive. All right, so if I just use the formula, we're going to have x equals r times cosine of theta. So it'll be 2 times cosine. Now, you can leave it as negative 200 degrees. I'm going to put 160 degrees in. I don't know. I just like dealing with the positive angles. Okay, that you're just going to put right into your calculator. And when you put that in, I'll round it to the nearest hundredth. It should be around negative 1.88. For y, you're just going to be put in 2 times the sine of 160 degrees or the sine of negative 200 degrees. It'll give you the same thing. Okay, when you put that right in your calculator, make sure you're in degree mode, you get 0.68. And again, kind of makes sense because this point is in the second quadrant, so x should be negative, which it is, y should be positive, which it is. So that point, negative 200 degrees, it's at the same exact location as negative 1.88 and then 0.68 for the y value. All right. And then number 3, you could do that because that's a special angle. You could do that without using a calculator. But really, the main thing, if you have a point that is in terms of r and theta, the main thing is you want to use these conversion factors right there to get the equivalent for x and y in the rectangular coordinate system.